Good evening, team. Welcome back to Advent of Code with me, Corey. Today, I think we're going to wrap up day 15, part 2. I wasn't able to get it solved fast enough last time, but I think I have a better idea of what to do this time, so I'm feeling confident. If you missed any of my previous days, check the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's dive back into day 15 here. So let's remind ourselves what we are doing. So we got a puzzle input like this that gave us coordinates for sensors and the closest beacon. And part 2 is if you draw all of those in a grid from 0 to 4 million, like, draw it out. So like here is the signal, sensor, sorry, here's the sensor, and its closest beacon was at one of these points. So we draw out all of the possible places where there can't be a beacon with the ampersands here. And if we drew all of these, oh, there's where the beacon is. And if we drew all of these, they would overlap. And there is a spot in the grid from 0 to 4 million. I believe this is 4 million. Yep. In the grid of 0 to 4 million that is not covered. And we need to find that spot. And then we do that, and then we do the multiplying thing, but that's fine at the end. The distress beacon is not detected by any sensor, but the distress beacon must have a y coordinate no lower than 0 and no larger than 4 million. So we tried a few different things last time we were trying to solve this. And our most recent solution, let's find our part 2 here. Let's just get rid of that for the moment. Part 2. Our most recent one, which didn't work very well, involved creating a really big array of booleans, of things where that can't contain the sensor, and then going over each sensor and marking where there couldn't be. The thought was the amount of sensors is like relatively low in my input. I think it's like 23. So it's not a huge number. It's just that the numbers of the coordinates are really big. So my thought was that I could go over each sensor instead of looping over each coordinate, and that might be faster. But the array is just way too big, and this just doesn't compile at all. And previously, what had I done here? I had found the safe locations. I think this is part 1 and some of part 2 put together. We were looking for something where the Y could fit. I'm not positive what this was. This was another one from before. But I think we're going to go with something a little bit different today. I have a new idea. We're going to keep parsing the zone because we definitely want that. And we're going to do let mutable x equals 0 and let mutable y equals 0. We're going to go through the coordinates. So while y, so I want y to be my outer loop, while y is less than 4 million. Let's make 4 million a constant, actually. Oops. Const. Oh, actually, let's just do it as a generic constant up here. Max. And I want to make this, I think, an I64 because I think that's what all my other coordinates are going to be. So while y is less than max, and then we are going to start x over because that's what we're going to be looping here. And then at the end, this is going to be y plus equals 1. So the y's actually could probably just be like a more standard for loop, but we're going to make it a while loop anyways. But okay, so while x is less than max, so same thing from the m here, or the x here. And then we can do let c equals a coordinate from x comma y. Okay, so what do you... Oh, it's just mad that it doesn't return the right thing. That's easy to fix. Okay, awesome. And then here, x plus equals 1. It's not always going to be 1 here, which is going to be the trick. But the basic idea here is we can do if... Yeah, okay, so we want a method. We want to do let biggest jump possible. Because if we look at the map again, that's what we're going to define a variable called. If we look back at the map again, if we were to find a random spot here, and we determine that it's covered by this sensor, right? We know, and we're just trying to scan from the left to the right, we know exactly how far to get to here, because it's the Manhattan distance from here. So like, we can determine exactly where to jump as the next coordinate in line. So what I'm thinking is for any coordinate, we can find the max jump you can do. So if it's covered by this sensor and this sensor ends here, but we're also covered by this sensor, and maybe this sensor's ends like way over, or maybe it ends like right there. I don't know. Right, that doesn't make sense for shapes, but it could end somewhere different, and we could jump to there instead. So we're gonna try to find the max jump possible. So biggest jump possible is gonna be self dot biggest jump possible to the coordinate, and then we let the jump in the x direction equal if let sum. So if the biggest jump possible is something, then we just use biggest jump possible. But if it's not, then we just use 1, and then we add jump x to x. Oh, this needs a equals biggest jump possible. I think this could probably just be an unwrap, or let jump x equals biggest jump possible dot unwrap, or 1. Way simpler. Awesome. Okay, so now all I have to do though is implement this biggest jump possible thing. Oh, and this isn't self, this is parsed. And this just doesn't exist, but I think it shouldn't be too bad, because this is on a zone, and a zone has sensors. So this is going to be self.sensors dot iter, because we're doing something over all of them, and we're going to do the we're going to map it to, okay, so what does this return? It returns an option of a usize, because the biggest jump possible. It could just be an I64, because that's what my coordinates are, and that's what we're mapping them to. So maybe let's do that. Okay, so we need the biggest jump possible for a sensor. Oh, for a sensor. Oh, okay. Yeah. I'm sorry. I forgot that this was a sensor. I just need to go one more level down. Sensor dot jump for the coordinate dot max. Generate the method. Jump for, so this actually returns an option of an I64, because there might not be a jump. There's not a jump if this sensor doesn't cover it. But what I also wanted to do is the return type of this is wrong, because we don't know that there's a sensor. I guess we could actually just unwrap here and say that there is at least one sensor. And then this would flatten to one option now, because we just unwrapped one of them. Okay, so jump 4. So what do we have here? Distance to closest beacon, and that's a U64 that we just keep, but that doesn't matter how we keep it. We have it already. Okay, so okay, so I think I just want the diff. If so, let x diff equals c dot x dot abs diff self dot oh wait, no, self dot sensor dot x position. What is going on here? What's self? No, I know self is just a sensor, but sensor has a position. Okay. Yeah, wait, isn't that right? Did I just miss the semi? That's all that was missing there? Gosh darn it. Okay, we get the y diff. Let dist equal x diff plus y diff. If dist is greater than if it's greater than the self dot distance to closest beacon. Then this is a none. Else it's a sum. Okay, but now we have to determine the sum. It's a sum of to do, sure. Okay, so the y, so the coordinate, the y diff. I don't care which direction it is because it's symmetrical on both sides. I just care about the y diff. So we do if x diff is greater than or equal to 0, then we do self dot distance to closest minus y diff. We jump this many. Oh wait, this might be, oh no, that's not quite the answer. Else minus x diff actually. Because the distance, we've already done y of the distance and we've already done x of the diff. Oh wait, no, actually I'm not reading this. I need to figure out which direction the diff is to. Okay, so starting from the coordinate, if the position, if the sensor's to the left of it, I want to do these backwards. I want to do these with self dot. I want these to be relative to the position. Yep. And this is C. Okay, so, cool. This is the first time I'm doing anything greater than 0. So if the position, if it's positive, that means that we're already on this side of it. So we only get to go a little bit more. So the y diff tells us how much we went in the y. So how much is available totally for the x. Right? Yep, totally for the x. But if we've already done some x, we don't get to do all of it. So we subtract away x diff at the end. And it's the sum after everything. But in this case, we add the x diff. Because that's what we need to do. Okay, this is as I64, and this is as I64. As I64, as I64. Open let close dist to beacon equals self dot distance equals beacon as I64. This is dist to beacon. This is distance to beacon. This is dist to beacon. And actually I should do let possible distance x or width given y position equals dist to beacon minus y diff. Width given the y position, width given the y position. Okay. So if the distance is greater than it, then we do that. If it falls inside, then we can do the math. If you're on the other side, then you have to add the diff because you do the width and then plus the distance of the diff. Oh, this is never gonna be less than 0 because that's just what it says. Of course, it's never gonna be less than 0. Self dot position dot x minus c dot x. The reason it was never going to be negative is because I did an absolute diff. It does a diff in the absolute value. It was never going to be negative. That's just what an absolute value does. But normal subtraction can be negative, so that's what we're going to use instead. This might mean that I actually just want to add this or subtract it. I think it does, but I'm gonna leave it for now and come back to it if things are working. Okay, so if we have the jump from and we have the max jump from, I think that means we're ready to go back to where we were writing, because this just does the max. No, let's write, I wanted to write this test to confirm. Um, I do this whenever I'm not confident about something like this. I just write a little test to prove it. Prove option ordering works as I think it does. Okay, there we go. Assert that none is less than option of 1. As a U64. Oh, that's why I said option. I wanted a sum. Yep. And then that, like, just that everything works the correct way. Run test. Yay. Did I need that? Nope. Awesome. Okay. So I just wanted to make sure that none was less than some, so the max works correctly with the case of none. It definitely does. Cool. Okay, so I think we have the max jump for thing correct. So let's get back to here where we just find the biggest jump. If there isn't a biggest... Oh, wait, no. We don't want to unwrap here. No, 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 no. Let jump x equals if let some x equal biggest jump possible. Then we do x. But then, haha, in the else case, this is where something gets interesting. What we actually do is we just return from this whole thing with the coordinate. Except we don't do coordinate here. We do coordinate x times the max plus the y. And I think that's the right order. I want a U size. I don't actually want a U size. I want an I64. Make math easy for myself. There we go. We don't take in the max here. We take it in as a constant parameter here. Oh, and actually, though, this isn't max. This is, like, what do we call this at the end? They gave it a fun name. It's the tuning frequency. So this is like frequency parameter. I don't know. The frequency parameter. Frequency parameter. The frequency. And actually, no, I should just do this. Const frequency parameter equals 4 million. As an I64, because this one isn't changing for either of the examples, so why should I pass it in at all? Uppercase. Okay. There we go. I actually think this'll work. Panic. We looked at every coordinate and didn't find the hole. Okay. I think it'll let me compile now because this panics and it's fine with that. Because I shouldn't get there because we should hit this return. That's the whole idea. Let's test out part 2 on, so we don't do it this way anymore. This is just the 4 million for mine and 20 for this one. And there is no second parameter there. Okay. Is this right for the example? It's also taking longer than I was hoping. I was hoping this was going to be pretty quick. Let's start debugging out the coordinate just because I'm really curious how long this is actually taking. I was hoping we were going to be hopping through these a lot quicker. Nope, let's not cargo test the whole thing. Let's just run the one I need it to run, which is this one. Oh, okay, so we're looping at 0, 8. So I think then what I'm gonna guess the answer is that here, I want to say if it equals that, then we don't have a jump for. Now, if we're at the absolute edge, there's no reason to say we can do a jump. It's just moving one over. Oh wait, no. That's not quite right though. So is this, do I need to add a +1? Is there just a plus? Hmm. The biggest jump is this +1. Okay, I just add 1 to whatever number we get out of here. Yeah, because we can get it to the edge, or I could just add 1 to either to both of these. That's fine too. It doesn't matter. Let's try that. Because you want to get 1 outside. I think I was getting 2 the last spot, and I want to get 1 outside. Example input part 2. Failed. Okay. So we got the answer of 8 back. Oh, cool. So we got coordinate 0, 8. We made it to coordinate 0, 8, and then we just got that as our answer. But the right coordinate, there is only a single position that could have a beacon, 14, 11. Yeah, okay. Um, yeah, okay, the closest beacon is here. So I'm trying to find one. There could still be beacons that just happen to not be the closest beacon to any sensor. Consider the sensor at a 7. Yeah. Okay, so I'm trying to find that the distress signal is coming from a nearby beacon. Yeah, so I have beacons. I'm just trying to find the one with the distress signal. You need to determine its tuning frequency, which x coordinate by 1,000,000 and adding its y coordinate. Okay, so why do I think that there's nothing for 0, 8 though? 0, 8 should be covered by one of these. This one. Oh no, 0 is the y, 8 for the x. This one should be covered by one of them, but it's not. Why is it not? Okay, so the max, let's just print out some stuff, I guess, but I guess I know what's gonna happen. The jump 4, okay. Distance to beacon for any sensor is this. Okay. We take the x diff. This is the position x absolute diff cx, and this diff. The total distance is this, which I totally am doing somewhere else, right? Whatever. Yeah, that's the Manhattan distance. That's all that is. And then if the distance is greater than, or maybe it's just this. If the distance is greater than the distance to beacon. Yeah, okay, yeah. If the distance is greater than the distance to beacon, we return none. Else we return the plusing one. That was the problem. I did both equals to and plusing one. Those weren't both right. Because what was happening is in the equal to case, we can hop 1 over and just get out. So that's fine. Not none. None means we're done. I was saying we're done when we were at the edge of an input. Not done. Okay. We looked at every coordinate and didn't find the hole, it says. Except 15,9 is the last coordinate. Oh, 15,19. Yeah, we didn't look at every coordinate, but we did look over all of them. 1411. There's only a single position that 1411. So do I look at 1411 at all? Let's go up to where 11 would be. Nope, I go from 1011 to 1811. Okay. So at 1011, let's figure out what the max skippy thing was. Okay. Function, uh, test, jumping. Okay, we don't take anything in, and we're gonna parse this one. Let parsed equals, yep, okay. Parsed dot biggest jump possible for the coordinate of x equals 14, y is 11. let jump equals that. Search equals jump, and I want it to be like some oh wait, no, not 14, 11. I wanted it from 10, 11, and the jump I think should be 4. I want to land right on it. That seems reasonable to me. What do we get instead? We get some 8. Okay. So biggest jump possible. Let's do jump 4. Let's do debug out here, a reference to self, and um I guess I want the whole answer. Let answer equals this. What don't you like about that? Let expressions are not supported here. Let answer equals if. Oh, I didn't realize I did a double let there. Okay, there we go. Let's run this. See what we see here. Okay, so there was a sensor. It's the sensor at 8.7, and the closest beacon is at 210, so the distance is 9. The answer I get is 8. So yeah, we jump to, yeah, we get some 8. Okay, so there's a thing at 8.7, and I'm at 10.14. So 8.7 and 10.14. Okay, I need to draw this out. This might be the easiest way for me to do this. 8.7. Well, wait a sec. Which direction do things go? Things go this way and this way. Yep, okay, so that'll work for my Excel sheet. Ah, too many things. Okay, so my Excel sheet. We want 7 in the Y and 2, 3, 4, 5, 6, 7. These need to be, no, this is gonna be too hard. It's just not easy that way. Okay, I can look at it here. 7, 7, yeah, 8.7, right? Because this is X. That's what it is. Yep. Okay. So that's actually this one here. Perfect. And I'm looking at point 1014. Oh, it's actually this one. 8.7. Okay, and I'm looking at point 1014. So I'm looking at point 1014, which is like right here. Right? Yep. And this beacon's over there, but that's not super relevant. Okay, so 8.7, and I'm looking. Wait, sensor is 8.7. Yep. Okay, so this one's a few over from the 10, which is fine. The 10's in like this line. Oh, 1014 is the end of this one. Right? 1014 lands me on the edge of this one, I think. 8.17. And we add the 9 to here. Wait a second. No. My position. I need to log out my position here because I'm losing track. I'm losing track of what's going on. Okay. Oh, I don't have access to that here. That's reasonable. It's 1014 though. So let's run this again. Okay, so the point I'm looking for is the 10, 14 here. Oh, 10, 11, not 14. I'm at 10, 11. 11. There we go. 11's this one, and 10 is like 2 over from that. Okay, so it's here. But it still should be 1, 2, 3, 4. Yeah, my answer is 4. Okay. Yep, the distance to this one is 1, 2, 3. 1, 2. So 1, 2, 3, 4, 5. And the distance is 9. Yeah, so it should be 4. Okay, so yeah, what's going on in this math here? Let's just log out some stuff. X diff, Y diff, distance to beacon, width given Y position. Okay. Debug basically everything. And okay. The X diff is 2, the Y diff is 4. So our distance is 6. Distance to the beacon is 9 with given Y position. So if the Y diff, oh wait, given Y position. Because if the Y diff is 4, that means I'm 4 either at the top or the bottom. So that means I've already taken 4 of the distance. So width given Y, yeah, so the distance that I could move would be 5. But that's not the right answer. And then how did we get to 8 from there? Width given X position. And then we added the X diff to that? No, I should have subtracted the X diff from that. Yeah, to get 3. Okay, so do I just have that wrong? If the X position minus, if the position of the sensor minus the position of that. Oh yeah, if it's less than 0. Oh, okay, I was doing that backwards, I think. There we go. Okay, now we get the correct sum there. Oops, there's a lot more than one line to delete. Okay. That works now. Perfect. Moment of truth. Does. Example part 2. Ooh, it does pass, and it passed pretty quickly. My input part 2. Okay, it's thinking. It's thinking. Okay, I think I want to print out. Oh, nope, we got an answer. We got an answer. We got an answer. It's a big answer. Let's see if that is our answer and if the copy paste worked. Copy paste worked. That's our answer. There we go. Okay. So we were able to solve day 15 part 2. The jump skipping solution that I had thought of did serve us well. From each sensor, we could figure out how much we could jump to get out of its radius. And then for each position, figure out what the biggest jump we could make possible, make that jump, and keep going one by one after that. Thank you for following along. I had a lot of fun here. I'm going to do day 15 live on Twitch on January 16th. That is also probably going to be the day this video comes out, though. So if you're seeing this right away, follow along on Twitch. But if not, the video will be on YouTube shortly. I hope you enjoyed, and give it a like if you did, and a subscribe for more videos. Thanks for following along for day 15. I'll see you next time. Bye.